So let's graph this. Here's our exponential. And there's our vertical line at x equals 1. And bounded also by the axes. Let's highlight the bounded area. What are we rotating around?
Wow.
Ooh, around the x. So what's going to happen is if I were to map this on the bottom, it's going to look something like this. And let's also make our little circle for the rotation. And then let's kind of exaggerate it. I have something on the top, something in the middle. Is this one a washer?
No.
No. So looking at this, my top one is part of the exponential. So y is equal to e to the power of 2x. The middle one is the x-axis, which is y equals how many? 0. And we're looking at pi r squared. So to find the volume, kick out the pi. And this one is with respect to what? X. So on the x, we're going from 0 to 1. And then we're looking at top minus the bottom, since bottom is just simply 0. Are we okay if I ignore that part?
Yes.
So e to the power of 2x to the power of 2, because it is r squared dx. That 2 is a little wonky. Oh no. And notice the choices are just a setup, right? So which one is going to be equivalent to what I have right now?
C.
Is it like kind of like pixelated right now a little bit? Okay. Does someone say C?
Yes.
Okay, now let's look at number 12. No, not 12. Did we say 12? Yeah, we did. 12 and 15?
Yes.
Okay, Abigail, let's read number 12, please.
Let R be the region between the graphs of y equals 1 and y equals sine of x from x equals 0 to x equals pi over 2. The volume of the solid obtained by revolving R around about the x-axis is given by.
So let's go ahead and graph this. So we have y equals 1. This is y equals 1. And then we have the sine of x. And for the sine of x, it's going to hit from the 0 all the way over down. And it looks like we don't need all of it, but if it makes you happy, continue. And the peak of the sine of x is pi over 2. And what else are we bounding with? X equals 0. And since it's supposed to be touching right there. Since x equals 0 is a vertical line at the y-axis, it looks like we're looking at this graph. What are we rotating around? X-axis. So we're looking at with respect to the x again. So if I were to rotate in that manner, this is going to map in this way. So would this be just a circle or a washer? Will it just be a circle? Is there a gap anywhere? Anywhere there's a gap, it's going to be a washer. So if it makes you happy for me to go ahead and graph this, as we go lower and lower and lower, there's a center circle as well. So let's go ahead and exaggerate. Ooh, I might not have enough room. Okay, I'm going to go over here. So imagine making a circle over here. So here's my circle. And then I have the inner circle. The center is shared between all of them. So our top is y equals 1. And then the inner one is our curve, which is y equals sine of x. And the center one is y equals what? 0. So we're looking at pi times the quantity of capital R squared minus little r squared. And then since we're looking at, let's just go ahead and write out the formula behind it. Pi is going to be kicked out, the integral, from what to what? 0 to pi over 2, very good. And we're looking at the big R. Looking at the big R. It is 1 minus 0. Do I care about the 0? Just going to write 1. And it's all squared. Although that really doesn't matter either. Minus, now we need the little r. The little r is sine of x minus 0. Do I care about the 0 again? No. Sine of x all squared dx.
Could we just do 1 minus sine of x squared
No, because if you do 1 minus, that 1 is a negative. Right now, 1 is not a negative. Wait, was that the question? I think I heard the question as sine of x minus 1.
No, I was just asking if we can just write it. 'Cause it's
Yes,
like,
you may.
Can we just do like parentheses and
Uh-huh.
1 minus sine
Yeah.
x and square the whole thing?
Because squaring the whole thing at the 1 is not going to matter, right? And then, which one is going to match this?
C.
C is going to match it? Ooh.
Wouldn't it be, yeah, wouldn't it be?
Are we squaring the whole thing or individual r squared, individual r squared?
Individual.
So it's got to be?
E.
E it is. Good job.
Oh, wait, that was my
It looks the same though, right? It's quite
That was
disguising.
my question was C basically.
Yes. So we can't say that because we're not, if I'm saying x squared plus y squared, it's different from x plus y all squared. Okay? Now let's go on to number 15. Let's see. Ryan, let's read number 15.
Let R be the region in the first quadrant enclosed by the graph of y equals x plus 1 to the 1/3, the line of x equals 7 to the x-axis and the y-axis. Volume of the solid generated when R is revolved around the x-axis is given by.
All right. Has it been a while since y'all graphed 1/3 x?
Yes.
Kind of? A little bit? Okay. So the parent function is going to look like this. The parent function looks like this. But that in the inside, Hannah, is telling us we're going to go to the left one a little bit. So if I were to do a little quick sketch, now it's not going to be perfect. I'm moving that over to the left a little bit, meaning it's going to be a little bit higher at the y-axis, something like this. And x equals 7 is this graph with the bounded coordinate axes. So our graph that we're looking at is this one. Where are we rotating this one about? Revolve around the x. So when I go around and mimic what's happening to the shaded region, it's basically kind of like making a side bowl. So if I make my circle, is this one a single circle or concentric circle?
Single.
It is a single circle. So let's write on here, we have with respect to the x. And it's our circle one, which is pi r squared. And if I were to exaggerate the circle, I'm going to get something on the top and the middle. My top is the 1/3 equation. Y is equal to cube root of x plus 1. And then y equals 0. And again, do I really care about the 0 on this one? Nope. So for the volume, we have the pi is going to get kicked out. We're going from 0 to 7 because it's bounded at the y-axis. And we have the whole radius squared. And be really careful. The x plus 1 all to the 1/3 is the r by itself. But I want to also square it at the very end, dx. What would that simplify to on the answer choices?
A.
A it is.